All right, everyone. Just getting the stream software banged out, and we'll be off and rolling here in just a second. All right, let's see here. Let's make sure everything's configured here. Aux one, boom, boom, boom. I'll put stream two. I shouldn't need these, but I toss them down. Really, I guess I'll do a little bit of jamming, and let me see if I can get some jams playing here. Let me do mic check, mic check. If anybody can, if anybody's on, just give me a quick mic check. Let me know if you can hear me. Reading 5 by 5. Hey, Bruce, can you hear the microphone? I'm gonna like crack in here in just a second. And so we've got all the individual components designed out. Water pump, hot water pump. The AC to DC driver for the PC fans. The bulkheads for connecting the water tubing. I'm just going to go ahead and throw a 25 amp power switch into the mix. I'm at debate if I want to add this guy in. I mean, I did buy it. It's pretty cool. I don't know if I want to roll with it or not. I may just do a direct power plug, like no switch included. So here's the I'll show you the water cooled concept that I've already showed off. In case you're new to the stream today, I'll show you the and browse. Just gonna throw some beat on there. Thought I had a yeah. Let me my audio over there. All right, so this is the original prototype here. A lot of you have seen this one already, and it's gonna look pretty similar. I mean, what you can't see is there's a water pump that's not a real water pump like the one I just showed you. What I got here, 100 millimeter eye loop. Okay. All right. So let's get to designing here. So you actually get to see this thing coming to life right before your eyes. This is how the product gets manufactured. You gotta, hey Juan Escuero. If I hopefully I didn't say your name wrong. I got your cigar can of mold. I had it printed up. Look, here's a print I'm doing for a shipment to Peru. I've got a shipment going to Peru. I made this gentleman a design. We're trying to get through the Peruvian customs, getting some of our genetics or seeds to him. And let's see, no, it's not there. So here's what I made to try to bypass the Peruvian government. I'll show it to y'all real quick. So I got a lab container that will hold, seed vials, like standard seed vial. So you can see right here. Let me. So here's your seed vials here. That we normally ship your seeds in. And I sent a shipment, and they like freaking rejected it, man. But they're a different country; they can open up the box. So it's not like in the United States. It's you have to have a warrant to open up someone's freaking box. So here's the body to the top, and then I added this angel on. Let me show it to you. So basically, this screws together, and you won't really be able to see that it screws together to hide the seeds inside. So I put these little crosses on here. Say more Dios, more por el Peru, love for Peru. If I make this see-through here, you'll be able to see that it's threaded. So so it's threaded here, and these seed vials are down below. And so I put a statue on top. So when it all comes together, it looks like one part. You can't see that it comes together, and it's like, got something inside of it. Then I designed these screw-on crosses right here. So they screw on, and if you look real close, you'll see that there's enough room for this to lock into there. So you can't just you can't just unscrew the top. Like this top will not unscrew. Let me hide that in blue. This whole piece right here, it will not unscrew if those crosses are not taken out first. So the crosses have to be removed first. They're kind of like the key on both sides. Then the top will unscrew. Now, what I can't do in here is throw on a model. Can't put and do any like a little statue. I got like a little angel statue. Let me show you. So here, I'm going to open this up here. So this is like a kind of known angel statue in Peru. And so I put this on top. So basically it'll print this lid is got this statue on top, and I did the lid all in black. And right now you're actually watching it get 3D printed right here. So if I'm going to prepare, this is how it's going to look. This is going to be in all black, and then the crosses are in white. And right now you can see it actually getting made right now. Switch over to the cam feed. It's getting banged out. Pretty cool, huh? Yeah, I go through the effort to get seeds to folks who are ordering from us. I like I don't like the fact that I couldn't get it through the first time, and that the Peru government denied it. And it's like, come on, man. I mean, the weed's like, I think legal. I think they let you legally carry drugs in Peru. It's kind of shocking that they denied a basic shipment. So now I'm gonna send the spell shipment to my customer out there. All right, so let me close this out here. And this is a bulkhead for the water tank. And I got to design a whole new water tank to spec to hold like a 1/4 gallon of water. I think I'm going to keep the intercooler kind of compact. So I'm going to be basically designing this right away from scratch. So right now, here's how far I got. I got the bottom chassis, and then in here is a polycarbonate glass, kind of a act as screen protector. This will get pop riveted into place. It'll be held into place. Now we got to have the LED light board sitting on something, so it's going to go here and here, here and there. It's going to sit on there, and I've got to put some brackets here in the side as well. So I'm going to go ahead and design those out. Call these long bracket. And okay, want that 10 millimeters off. Okay, so it shows I have an angle on there. I need to redo it. Pin high. And let me get back out of here. Let's do new sheet metal component. We're going to call this short bracket. Short bracket. Throw the lines in here. Okay, we're going to do flange out, 1-inch flange, 1 inch. That. Let's do another one. And what we do to one side, we need to symmetrically do to the opposing side. So we're going to go ahead and do a feature copy here, that and that, across this plane here. So what you see here, I'm actually going to build the real one. You're getting to watch the process of designing it. And then after I crank it out, because I did all the hard work, all the components to the left side over here on the screen, that takes a lot of time. I did that on a non-live stream just because kind of a dragged out thing, recreating components and stuff. So I'm going to make this face here look like glass so I can kind of see where I'm at, get a visual here. I think I'm going to do this face as well here and here. So we need to shoot some pop rivets through here. And I think I'm going to go ahead and some holes right here for mounting. 3.9 millimeter. Gonna put a couple across here for strength. And want some dimensionality there, so I'll do 40 from that one to that one, 40, that one to that one, 40, that one to that one, also 40. I think I got room for another hole here. Let's do that, and then let's do negative 80. So instead of doing the 80 mark, I'm going to put that one dead center at 85. Now we're going to copy this work here, mirror it on over to that side so that we have perfect symmetry from one side to the other side. And now we're going to go ahead and we're going to cut through. Oh, something went already there. There we go. All them holes cut through. Bang, like that. So now I can put some pop rivets into these holes here. And I do have a rivet here. I can go ahead and computer draft this little rivet. So we'll go ahead and do that. I'll add that in as a I'll just quickly crank out a rivet. But as you can see, to put the rivet into the model, it's going to be quite a few rivets. But we're going to have to do it. It's a requirement. We have to do it. So 3.12. Kind of one of these holes are a little bit big here. .12. Let me check this out real quick. 4.72. Another doing measurements here on parts. Okay. So I need to go back in here and edit that. I want to tighten up the holes a little bit. I kept remembering a 3.9, but I need to do like 3.5, 3.8. Do a 3.7. Okay, I gotta unfortunately do that to each one. All right. So, okay. And then the others on the other side, they're all, so since this is polymetric modeling, everything is pretty much staying the same exact size. When I make a change, it makes a change to all the other holes automatically. So it saves me a lot of design time. But this is why I had to redo the this particular design, because the first one I made, I did not design it with, if you look at the hierarchy over here with the multiple components, I did not design it with a multiple component assembly style design. All right, so now we need to make holes in the short bracket, and I want to be able to see into the wall here. So we're going to do the same thing there. And put some holes into it. Actually, I need to come up a little bit. 7.5. We'll do that right there. And we'll copy these two on over across this plane here. And something don't look right there. Oh, I see the problem here. That's pretty strange. Let me come back to that. So unfortunately, I got to back her off here. Not that. Let's see. Let me delete this copy here. Yeah, that sucks. I'm gonna have to redo all that again. Got a little bit of a symmetry complaint going on there. First one's good. I'll put the holes in after I get the oh, there we go. I see our problem here. That's not gonna work out. That's not gonna be kosher here. I come back a little further. So I'm going to do is I'm going to copy the bracket, make a second one. Point 5, 7 should be enough there. All right, I got to make that bracket again. Another one on the side. Do another component here. Sharp bracket. Five, 9, 5, 5. 0.2. That'd be close enough right there. So we're going to have if you look, we look down in here, you see we got the lens right here in blue. This is a polycarbonate lens. That way you can't touch the diodes. And plus, it keeps all the heat trapped up inside. Now we need to design the plate that actually holds the diodes onto it. So we're going to do that right now. Okay, we're going to fill up the corners here. Round them off right about yay much. Got a 26 radii right there. Let's do it again. 6. Other one. Boom. All right, now we're gonna new component. Raise this up 0.125 inch. There. So now we have the board that's gonna hold the diodes. Let me hide the polycarbonate lens so we can see up in there. And you can see that it's basically that is sitting on top of those brackets that we just got through making. So now we're going to start working on putting some holes for getting the power into here, into that board. And then we'll start putting diodes on it. And I'll do a 1 inch. And 1 inch hole should be good. Oops, let me keep the design flow proper. Bloody diode board. Inch. Boom. Actually, I'm going to go ahead and cut it all the way through here. Cut all the way through. So we're going to have one bracket that's completely cut through while the other one is not. Come back over here and check everything out. Okay, hide this board. I need to check and make sure we can do a flat pattern with the design. This is showing our bin lines for metal brake. Yeah, sorry guys, it's just a design live stream. Not the most fun stuff ever, but I got to get it cranked out. Plus, I always chop video parts and segments out of my live streams, and then I use them for other videos I produce. Okay, I gotta create that. Okay, looking good there. All right, back to design mode here. All right, so if I hide the board, we have our 2 points across there. Let me bring the board back. Let me cut some holes into the bracket here. Very tempted to. Let me scope everything out real quick. Getting a good visual here before I shoot these screws in, or shoot these rivet holes through. All right. I think I'm pretty safe to shoot holes through that. Let me go ahead and make that see-through as well. Right there, and right there. All right, now I can see through the whole thing. Okay, I see that my board, I have good clearance for my LED board here. And I'm going to go ahead and shoot the holes through. .5. Yeah, 3.75. All right, I'm going to dimension that. I'll do 50, yeah. 50. 50. 50, and center hole here. All right, time to mirror cut that, or mirror that. Mirror, boom. Done. All right. Look pretty good there. Oh wait, everything is overlapped and there's a rivet going through each part in the structure, keeping a very rigid grow light design. With it being driverless, it would typically be ultra lightweight, being sheet steel, but we're adding water on it. So now we start doing the fun stuff, like putting we're gonna have to put the water cooler on here. So now we're gonna start doing that right now. And I'm gonna go to my handy friend Chat GPT real quick. Use the AI, man. I'm going to use the AI. Let me go to ChatGPT 4. What is the dimensions box to hold a fourth gallon of water? Where the box has a 2-inch height. It's going to basically divide 57 cubic inches. Oh, yeah, 57 cubic inches, okay. And then all right, so 7.6 by 3 inches by 2. So let's do that. 7.6 inches by 3 inches. It would go too high, but looking at that plate here, I think what I'm going to do is I'm going to keep the diodes kind of like pretty close to the to this water cooler, so that the rest of the aluminum plate will act like a natural radiator, like a natural heat sink, while most of the heat is being absorbed right there at the water cooler. Let's see here. We're gonna do an inner box here. An outer box. And that actually has to be sheet steel. Actually, no, it's not. Never mind. It's going to be 0.812 millimeter. New component. Okay. And now I need to make a base. Right now we're going to go ahead and switch back to sheet metal design. New component. Water. Reservoir. Okay. So I need to do 7.6 by 3.8 by 2. 3.8 inches. 6 inches. Yeah, let's do that. I'm gonna make the outer plate bigger. Okay, flange. Damn it. That's not what I wanted. Actually, let me 4 inches. 3 inches. me go 5 inches on that. All right. It's going to be galvanized steel. So it's this. This will be aluminum here. All right, now I got to make another component here. More. 3.8. 8 inches here. All right. Okay, I know what I did wrong there. That's not going to work. I'm going to go back up. I'm up 2 inches here. So 2 inches up. Three inches. 6 inches. And that is our base plate. We're going to shoot this guy down 2 inches. Freaking sheet still looks pretty thick. Let me check the rules on it real quick. Yeah. Set to the 812. There. That mo better. 2 inches. Here. All right, let me polycarbonate's hidden. Base plate. All right. Let's go ahead and flange this on the inside here. We're going to do 1 inch over. Same there. We're going to do 1 inch. Inch. We're going to come in here, kind of weld those seams up. I'm going to either use my MIG welder or I may use some brazing rods. I may MIG weld it to kind of just spot that up real good, get that up, get that going real good. I'll water test if it holds water. Great, I'll roll with it. I'm not like really a welder, so I'm going to kind of lean on some like brazing aluminum rods to make that thing watertight, and then I'll do the corners with a little silicone to kind of tighten everything up. So I'm going to metal bend it, and then so you can't have no holes in there. We got one more little trick that I've got to accommodate here. see here. Match there. Match. Oh, I can't do that. Leak. It's gonna be flat. It's gonna be flat. How am I gonna? So weld that there, and then we got the base plate here. So this will get welded to that. It's gonna be galvanized steel, so I'm gonna have to wear a face mask. Don't be breathing that shit in. All right, so I need to make the base plate a little wider. Go back over here. Slide. Actually, not 6-inch. Something like that. Needs to be a little wider. So what's going to have to happen here is right along the seam, it's going to have to get welded across here. And then these seams right here, this is going to get this wall to that wall. It's going to get spot welded. And then we're just going to kind of fill this in with weld. Use a MIG welder, tack all that together, kind of get that all done up. Then I'll run the MIG along this line and that line there, here and here. Get that all nice and welded up. But this base plate is going to have to be, the reservoir has to be welded to the base plate. I'm gonna MIG it all up, kind of maybe spot weld it, hit it in a bunch of different places. Throw this on the anvil. If you watch my videos, you know I have an anvil. I'm gonna toss it on that anvil, and I'm gonna blow torch the living shit out of this thing, and run aluminum, like an aluminum brazing rod, or aluminum rod, like a solder rod. Like I think it's like solder, but it's really good for like water tightening things up, and while still being strong. Now the other thing is I need some rivet holes right here. Yeah. Let me join these two bad boys together real quick. Like that. $295. Yeah, looks about even there. Let me come back over to the base plate here. I do need to make it a little wider. 7 inches. Oh, no wonder that is not working. I don't know what all that is. Let me get rid of that crap. It's confusing me. Don't know why that wouldn't let me go. 7 inches. Okay. There, that's more like it. So we're gonna bring back the base plate here, LED board, and I need to grab this whole thing and move it. So I think I'm going to do here, I'm going to keep this. Keep this floating about right there. Put a couple holes in it, a couple rivet holes here. So the purpose for having this wide outer ring right here is I'm going to throw a shit ton of like caulk, to some high heat silicone caulk to go around the edge here to make a good watertight fit. And then I think I'm going to rivet it down really good after I'm very confident that this thing is welded up good and it's going to hold water, and I'll rivet it down. So real quick, I'm going to go ahead and just cut some rivet holes here. We're going to do 3.75 millimeter. Actually, I'm going to need to put these long ones in there. Let me see what the... So 4.7, let me do 5.25. Okay. Halfway mark here. And I'm going to copy these on over. Oops. Then I had to do the same thing to the other side. All the way through. It's right there. Grab this guy, move it out the way. Now we're going to join it with precision. Computer precision. It's right there. Oh no, what did you do that? All right, you stay right there. It's not done. So now we need to put our holes into, we need to put them into the side bracket here and into our plate. Then we can start putting our diodes, start designing the diodes into here. And that is going to be a fun one. It's another questionable thing. I'm going to put holes in here, screw diodes down, and yeah, we're going to have some clearance. So it's kind of the, I guess the bulk of the work is really going to be right here on this plate. And then I'm going to cut this thing up. I'm going to make this grow light. I'll have all the cut files done. Monday I'll have them done and ready. I'll have some metal on order, and we'll water jet cut everything, and bada bing, bada boom. All right, let's see. I'm getting all stonered out here. Like, okay, let's go ahead and we're gonna look through it real quick. I can chop my holes into here. I need to highlight the board. Temperature position. All right, so I'm gonna put some mounting holes here. Wow, what are all those? Oh, okay. I'm gonna do 3.25. No, I do. It's at 4.95. Let me measure it again. Yeah, I'm doing like a 5 millimeter hole. 5 millimeter. It's all design stuff, and it goes together like, absolutely flawless. Okay. Now we're going to mirror that. Right there. Okay. Cut our holes through. Two objects there. All right, now we're going to change that back to aluminum. Take a look at it. All right, there's our mounting holes. Now I got a few more to make. Let me see, short bracket 1, short bracket 2. And 3.25 millimeter. It's just to support the weight of the grow light. And copy, just a copy paste. I forgot about a little keynote thing here that we're gonna have to do. Even though the two brackets are exact replications of each other, it's absolutely imperative that each one are entirely identified individually. So to do that, I'm going to cut a 1 and a 2 into each of the brackets here. Just going to do something like I'll just do a little simple drawing. Just a little marker that lets me know that this guy, ooh, what happened there? You see that funky crap? What the hell? Did I move my part? I did, huh? Let me undo whatever dumb shit I just did. And my holes are all whacked now. I shifted something. There. That's what happened. Like, what the hell? Definitely had something glitching right there. 5mm, I gotta do it again. This right here. Goes right over here. Oh, I see why. Oh, problem. Okay. I completely understand why that's happening. Because when you make a copy from one, so you have a short bracket 1 and 2. 1, 2. I'm going to delete number 2. And I'm going to back this off. So when you make a copy of something, anytime you're working with the copy, it will make the same changes to the other copy. So what I want to do is I want to paste, I want to copy a completely new part that does not share this behavior. Yeah, we're just gonna move that on right on over there. Right on over there, man. Just get a right on there, man. Yep. And it's okay. So this thing is not snug to the wall. That's okay, because we're gonna get it snug to the wall after I blast some holes in the first one. So 5mm. What the hell? What the hell, man? Do it. Do it. All right. Here we go. Bang, bang, bang. All right, we're gonna shoot. Now we're gonna shoot the holes all the way through. We shouldn't have this weird ass behavior. Yeah, none of that crap. But I do gotta go 2 sides, cut through here. So we'll go 2 object here, and then 2 object here. There and there. Let's see. Now let me check out the design. Got a peek in the little hole, man. It's like some geeker shit right here. Like, look at that. Looking at that whole right back chair. All right. Now remember that little part didn't want to line up. Let's fix that problem. We go right there. Booyah. Perfect. Precision. All right, now we got to cut some. I think if I put more rivets over here, that would probably be overkill. Completely unnecessary. We're just wanting to take the gravitational load. Let's see. Pick out everything that's going on here. That's Friday. I'm trying to just bang this out, get everything looking decent here so I can get it cut, get it made. All right, I gotta do my identifier here. Sketch 1. Cut through there. Okay, component. What the hell happened there? That's some weird shit. All right, I gotta do this bracket. Because what'll happen, like this side, if this side gets flipped to this side, whenever you're bending the metal, you don't know the inverse piece of artwork when you're looking at a bunch of, or the inverse piece of your component, because everything is freaking, you know, it's a 2D flat metal piece, and you got all these pieces you're trying to hurry up and bang out, and so it's easy. Not a perfect one or nothing, but it's easy to not know, like, first off, that this is the right side up. I could put a little arrow here, but I'm from building. Oops, let me back out of that. Select that bracket. From having built things, I kind of learned the hard way that best to make the identifiers. Well, see how I made this bracket here, and then now we have a 1 over here. So I was copying that component. I need to get rid of long bracket 2. Go back to the primary. Copy. Paste new. So going from a prototype design to the actual roughed out design, it's a big difference. And I'll go ahead and just do my what the hell is that keeping? What the hell? Long bracket 1. Okay. There we go. Well, that was a dip-tard move. Let me switch it back over. Boom. All right. A little minor correction there. cut. Revert that back to metal. So you can no longer see through it. Two. All right. One, two, one, two. 1, 2, 1, 2. All right, got those identified. Now we got a little bit more, work to do here. Let me throw a plane. We'll do just 5. We'll do 10 millimeters above. Actually, let's drop that down. Let's do 5 millimeter. All right, so this plate has to go above the water core, the inner core. So we're gonna. This is the plate that's gonna hold like all of our PC coolers and everything else. That's how I've got it figured out in my brain, anyhow. Yeah, we'll come all the way out here. Actually, no. We'll come out really far. Oh, totally screwed that up. New component here. New component we're gonna do radiator shield. Did I spell it right? Radiator? I'm kind of fried right now, man. Let's see here. Let's change the sheet metal rules to 812. All right, now I'll go back to offset plane 5 millimeter. Get a center hole here. Center design. Okay. Flange that out. Now we need to do I got to do something real quick. All right, from bottom there to there is what? 56.612. Okay. So maybe it was okay. We're going to flange that down there. Flange it down to there. Yeah. Let's do that 3/4 inch. And 10 over here. 25 inch. It's like all my power cords and stuff coming in here. All right, we're gonna have to make some holes through things real quick. So we're gonna start bringing in some parts. It's about to start accelerating now. So the first thing I need to do is bring in my bulkheads. I need to bring in one of these, copy. Oh shit. Body. Copy. Paste. I don't like that. I mean, okay, so it's not gonna let me copy the whole damn thing. All right, I'll just do the bulkhead for now. Do the whole thing. It's kind of a. I mean, behind the radiator shield. No, what the hell happened there? Okay. Paste new. So we're gonna have an in and an out going on here. And I think I purposely gapped it for. Yeah, I did. Look at that. See that gap right there? Oh, I love me because I thought ahead. So before I get too excited and all happy and all that fun shit, let's let me get a measurement here on the diameter of that. So 10.85. I think we could do a 10.5 millimeter hole. Okay. We'll do snap the line across here. Turn to construction line. Do 11 millimeter hole. We'll do 11 millimeter. Screw it. And construction line. Copy that. Perfectly across. Negative 0.812 millimeter. Cuts our. What the hell is that? Oh, you know what? Where's this? How did that not pass through? Sheet metal rolls. Oh, well, that would be why there, champ. 0.812. 2 millimeter. Yeah, now we have the holes through there, and now everything is thin like it's supposed to be. I gotta correct that crap too. 812. Thin up. Yeah. All right. It's like, man, that's some thick looking freaking metal, man. Like, it's gonna be a bitch to bend. All right, let me fix this one here. Let me update flat pattern. Okay. So when everything's done right with parametric modeling, you can go back through and make a little correction, and it will like automatically readjust everything without like totally screwing up your design. Like everything won't be screwed up. So now you can see that metal's thin now. So everything's looking pretty good there. Let me throw back the update flat pattern. Let's bring back the LED board. All right, now we're in business. All right. So let me I'm gonna just combine these guys. Quit model. Capture position. New component. All of them combined. 1, 2. New component. Don't keep the tools. Bam. Okay. Solid. And then I'm gonna have these I can keep the same. All right. Like that. Just a bunch of bop bop bops. Bop bop bop. All right. Now our water will go into here, out of there. As we get some circulation action going on. Let's bring back our radiator bracket. So obviously what we need to do is, if I hide these bulkheads, we have no hole in the radiator bracket. So we need to have some holes for these to pass through. So we'll just go ahead and do something very simply like this. Let me keep some kind of symmetry going on. OCD was kicking in like, man, all 2 different circle sizes. All right, let me hide the bulkheads. Negative 0.125 inches. Oh, actually, negative 812. Oops. 2 millimeter. Okay. So now we have clearance room, bulkheads, clamps and shit on them. Clamp that all up. All right. Now we're going to I gotta bring in the PC radiators real fast. It's gonna be a biggie. Let me bring in the water pump real quick. We'll do that. Body. Sticker. Okay. Combine. Let's combine all of it. I'm just gonna do fucking really one to the other. Let me delete that shit. Delete. Fitting one, copy. Paste was new. Two fitting. That'll work. Bam. New components. IGP. Copy, and we come back over here. Paste new. Oops. Oh, I had a complaint. Did not like that. Copy. Better copy over. All right, I'm gonna have to do them one at a time. Save it. Oh, let's go and save it. Something's gone funky. My damn. All right, I'll try to copy that. Copy. Let's see if it'll complain. There. Oof. Just getting a little worried there for a minute. Did all that design work and be able to transpire it over? -78. -78. Try that. I'm switching. All right, let me get the connection tube fittings on. Copy. Paste new. Actually, cancel. Copy. Paste new. And paste new. I need to hide this board here. LED diode board. I mean, you can see I had the origin here. Faces. So you can see our brackets here. I mean, our bulkheads for the water. So we got some progress being made there. We're moving along now. I need to be able to see through that puppy so I can put some screw holes in there. I might have to screw that down. Oh, I didn't think that one through very well, huh? Look at that. That sucks. How am I going to keep that bolted down? I got the real pump. Look at it. So, move that out my way there. This thing. We get this damn microphone crap going on. All right, so here's the real one. Okay, it looks like I would be able to maybe get like a screw going into there. It's gonna be a motherfucker, man. Like, it is tight. Definitely need to revisit this pump design real quick. Something ain't looking right. 45. Yeah, that's my problem. All right, I gotta pull this whole pump out of here. Pull the pump out, come back over, and I got a problem here on my pump. All right, let me regander this whole thing real quick. 32 line. 45 long. 45. Two. 45. Like one screw up, man. You gotta go back and do it all over again. Okay, but this is okay. This was a minor mistake. Okay. So what I'm trying to do now, I've got to fix the little mounting bracket right here for this water pump. Fix this design real quick, and off we go. 3.56. All right, so 3.56. 3.56. 3.56. Okay. Going down. 6.5. 5. I was wondering why I couldn't get to the scrolls. I'm like, what the hell's going on here? It's like kind of crazy. 3.28 diameter line. Oops, 3.28. 3. 3. Okay. 3.36. Okay. Trim there. Trim there. And we have a repeated pattern here, so we're going to do that. Do that. Instruction line. Mirror that to there. Mirror that, that. Cross that line. Boom, 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 boom. Oops. There. That's what it looks like. Okay. Just enough room to get at the damn mountain holes. All right. So now we got that all fixed up. Let's go ahead and copy this bad boy. Copy. Bring it back into our design over here. Paste new. Bring it up. Turn it 90 degrees. Else. -5 maybe. Okay. So here I'm just gonna snap a hole. To 3mm hole here. Yeah. And then move the water pump up, and then we're going to precision join it to that hole. We're going to make any more holes. Voila. 8mm. You know how to computer draft stuff? That's like, $45 an hour. Especially if you're product design and you're fast, like as you can see, if you're fast like me, you're definitely up there in that $40+ range. If you can CNC machine the design, that now is putting you about $120 an hour. You can do the electronic design and machine it, and that typically puts you up to $250 to $300 per hour. We charge sometimes $12,000 to $15,000 for private designs that I never get to show you guys. I have to sign non-disclosure agreements on. There was one who did let me, Mr. Ryan Broadway, if y'all remember, that I made the hippie clipper shears. And then the video I have is not the completed video. Like, I need to show y'all what that pair of scissors looked like. It turned out really badass. Like, I made the metal blades and everything for it. It was really cool. All right, so let me bring over the tube fittings and copy. Paste new. Boom. Paste another one. After I build this water-cooled LED, this thing is actually not to sound negative or anything, but it excites me a little bit because the challenge for me is the waterproof. I'm probably going to run mineral oil in it. Some people are going to be like, dude, what if, if that's got water in it and something busts and it leaks out and it arcs, and it could be a fire hazard, or, it could shock somebody. So what we're going to do is we're going to put mineral oil in it. Now we're going to have this pumping mineral oil, because mineral oil is not conductive, yet it works great for cooling. So you can put mineral oil in it and cool it that way. And you can put high voltage and mineral oil and stick your hand in there, and you won't get shocked. It's just completely non-conductive. So that's going to have the screw hole mounts there. Now what I'm a little worried about is our total height here. We got 4 inches of metal break room, so that is a thing we have to watch out for. Secondary units. Ooh, we're really cutting it close, man. 3.89 inches. I don't know. Like, we are really cutting it close. I'm gonna have to move. Yeah, that's right. Unfortunately, everything I just did right there, I'm gonna have to. We don't have enough height. My metal brake cannot break past 4 inches, so we're gonna have to bring the water pump. I really didn't want to do this either. I really didn't want to bring it that low. Let me show these joints here. Suppress joint. Let me hide the water pump fittings. Let me project these holes real quick. We got our power coming in over there. Yeah, we're gonna have to stick it. Oops. LED board. We're gonna have to do the water pump on the back side of the LED board. Negative 0.125. Move those a little bit away from that edge there. Okay. Back to the water pump. Oh no, don't do that. Stay there. I gotta do something about that one. Move on you. So I gotta put some holes here. Okay. Okay. I was wondering why it looked a little bit thick there. Let me change to 8.812. Should get thin. Update flat pattern. Good. Good. All right. So now I'm gonna shift this plate out of the way real quick. Move that way. Oh yeah, she want to move everything out of the way. Create some precision joints here. Right there. Good, sir. You need to move here. And here. That. Okay, I'm just gonna put that there for now. I've got to put some holes in there for locking this bad boy in. Got holes in the radiator shield. And I already see a problem here. So 0.75 and there we go. That problem. Okay. Now we have some mounting holes. Capture the position. Five millimeter. Mirror on the wall. Copy to that line. Okay, that don't look right. Cancel. We'll come this route like that. Okay. We'll do that. And I'm gonna cut. So indicator here. I need the. When I'm bending the metal, I need to know this is facing the top. Like I'm looking down at this. I'm reading it from the top. Alright, should be. Let me cut all the way through to the plate. Right there. All right, now I got to move this thing out of the way. And we start. Oops. What the hell was that? Oh, yeah, there we go. I don't know why. Suppress. Move. Okay. All right, now kind of. If I bring the polycarbonate lens back, yeah, I had a feeling that was going to happen. Let me hide the reservoir and I do diode bracket. Okay. Bam. So we got our lens on there. Bring everything else back. Water pump where it needs to go. Ooh, little problem there. We'll get a kink. We'll have a real tight bend on it too. So we're going to want to move this water pump back a little bit. Let me go ahead and come in here. And move those up this way. Maybe about there. Okay. All right, there we go. Now we have good clearance. Good clearance from the top of our shield bear. Got some tube clearance for our flow tubes. Now we start moving some other fun stuff over. All right. We get to start checking some parts off this bad boy here. Nah, I got a 4090. It should be able to handle it. It's the CPU. Bottlenecking on the CPU. All right, let's copy. That's one radiator. I'm gonna copy one fan. I may, I may. I mean, I don't know. I may go with AC Infinity on this one. I don't know. It's those are really heavy. They weigh a shit ton. And I think I'll go ahead and. All right, we got to see if we're gonna fit. We're gonna make the cut here. No. This was the one little thing I was kind of worried about. Not too bad. I'm not too worried about it. We're gonna have to have a top plate. And we're trying to keep this thing really compact, so. Yeah, let's do that. Let me move that back out of the way there. Let me make a correction here to the sheet. Get rid of those holes there. And -0.812. I'm gonna have to come up here. New components. Yeah. right, now we're gonna have to make a couple little holes in this bad boy in order to rivet it in place. We're just gonna put 4 rivets in here. Should be plenty. Turn it into glass real quick so I can see through it. Do 5 millimeter. In the middle there. The only reason I'm going to build one of these, as you can see, I mean, it's going to be a lot of metal bending work, a lot of parts management. You bend it wrong once, you'd be in a mess of headache, you know, trying to do it again, get it right. Everything has to be managed with the word top on it to keep orientation during the metal break process, so that I know if I'm looking at the word and it's pot, I know that I've got my part is inverted. It helps me identify how things are supposed to be looking. Okay, so I'm gonna go ahead and mirror that to there. And we're going to go through negative 8.12 times 2. Damn it. 812 times 2. All right. There. I'm going to change this back into aluminum here, or back to galvanized sheet steel. All right, so now let me hide I'll hide the bottom chassis here. Here's our stack up. You can see the plate. Soon we'll have some diodes underneath here. We'll start putting grow light diodes underneath here. Pretty trippy, man. All right. Let's move this bad boy into place. Just kind of eyeballing it around there. Let me move it up on top. So Looks like maybe I didn't make that bracket. I didn't make this top plate long enough. It really needs to ride the edge, huh? Let me come back over here. Let's edit that. Make a little. Let's come back over. Take a gander. We're almost there. Dude, I think we got it. No. Only thing here I want to do, we're gonna have to make some I have to kind of project the sky. We need some holes here to be able to mount this into. I'm having a little bit of lockup there. This radiator is in pretty high detail, and boy, it is not liking it right now. I forgot I gotta be a little softer here on it. Just that radiator is a very complex part because if you look at all the inner grid, all the details on it, it's super high res, and it does it's a lot of computation on a computer. Even the graphics card that's $2,400, she's thinking, man. I'm running a 4090. I guess we'll just pop on. Let me scope out the 3D print real quick. It's coming along. Looking pretty good. Yeah, I think I pushed my limits here with what I just did. Let me pray that it can save. Okay, she's gonna crash on me. Let me go ahead and crash it, and let's hope I don't have a lot of redo work. That would suck. That's the problem. That's the thing. Like you have how you work with the intercomponents, how you work with everything. You have to be very cautious. I mean, I have a $7,000 computer right here, running 64 gigs of RAM. You know, just everything about it's pretty much high end. I mean, it's not the most latest greatest. So she's a few years old, but the 4090 and it cost me almost $2,500 for the graphics card by itself. So, you know, she's not this computer's not a slouch. Open. Let me hope it saved a lot of that, or I'm gonna call it a day and come back to it. Sorry, it's already 4:40. Okay, so it held it on. It held it for me right there. Let me do a quick save. Freeze this shit up again, and let me do a measurement real quick. I think we could. maybe do a measurement here to there. So it should be 120 millimeter. Let me double check. I'm gonna snap 2 lines real quick. Get her figured out. 105. Okay. So the mounting points are 105. I snap a line here. Here I should see the same thing. Yeah, 105. Okay, so 105 is the magic number there. Okay, makes sense. So, and then let me see how far apart are we separated. 15.240. Okay. So let's go ahead and do this right here. We're going to do, I have to do 105, 5, 5. Oh, I see the problem. It did not save the change that I made to size of the radiator top plate. So we're gonna have to go back through that. Yeah, that's about the only thing it didn't do. Finish. There. That's mo better. Save it. What the fuck? What the hell? What the hell, man? What the fuck was that? Go here. Don't vanish. All right, there we go. 105. And I forgot the other damn number. So we're gonna do 3 million. What is it? How big a hole do I need to make? I'm retarding it there. Let me, it's a 4.2 millimeter. It's a 420 millimeter hole. Yeah, that's pretty nice. All right, that's easy to remember. I can remember that. 4.2. 2. 2. 2. Oh, what are you, Daniel? 2. All right, let's move this up a little bit here. Okay. Was it 24.64? I forget. Let me pause that real quick. Let me bring up the radiator. Oh, it was 15.24. Okay, that's what it was. 15.240. Four zero. Two. Two four zero. So really do that to me. It did. It really did. Monitor. I got a different approach. 2.240. That, and we'll do this right here. Like that. Bam. Now it's not very centered. Maybe you don't want to move the whole thing. Unfortunately, I have to deselect all these little holes in the middle. It confuses the computer. That's pretty. It's pretty good there. Move it. That looks pretty good right there. And now we're going to copy it to the opposing side. All right. Now the fun begins. So we're making the screw holes here for the PC radiator. And then we'll be moving along here. Oh, you sucker. All right. Let's move this radiator out of the way here. And there you go. I did not like that. We do that. Back there. Bridge 17. There we go. That's what I was after. Boy, the design's starting to kind of lag down a little bit. the design's getting so complex now that it's really putting that computer processor to work. All right, so we got enough clearance here. Put our diodes in, which we're going to be working on here pretty soon. One fan. All right. Get back over there. Looks like a fucking Ferrari engine, right? Just looks beast mode, man. It looks fucking beefy, man. Now, the how high are we up though? Let's see. Gotta be careful about that. Inches. All right, we're just. I mean, from that plate up, let me bring back the bottom chassis. I mean, we were riding right there. And I got 90-degree angled host connector, so it just gives us a little bit of stress relief off of these. So maybe I'll have to come out of here, bend bend up and over out of here. Let's start doing the. Well, actually, I'm not gonna have that much height. That's right. I'm going with some different. I may go with different fans, and I may remove these fan shrouds. They won't really be needed. No one's gonna be touching the inside of the grow light. Still got to get them down. Crazy all them holes, scary. Like, oh, I'm putting it together and forget everything goes. Nah. That's why you make all the holes the same size. All right. She's coming together. Let me let's go ahead and bring in one of our other little necessary components here. And if I do all AC Infinity fans, she's going to be heavy. She's going to be real heavy. This is going to be really badass. It's going to be really quiet. If I use AC Infinity fans, it's going to be extremely quiet. But those fans are heavy. That's gonna add like 6 pounds. It's gonna be like a 35, 40-pound grow light. That's gonna be badass, man. All right, let's bring in. We need to bring in our AC to DC driver in case I do intend on going ahead and. Or actually, I do have to have this on for the water pump. Copy. Soon. I think I'm gonna put this guy right over here, out of the way of the tubes. I want a lot of clearance for the tubes on the business end of the cooling. I want the tubes to kind of be out of the way, and I want my AC power is all going to be coming in on this side and being distributed out. So let me go ahead and get this puppy mounted in. Okay. It's going to be. I'll do 3.75 millimeter here. So 5. And we'll make these mounting 3.75. So if you notice, I've been keeping consistent with everything. Premise that I may hot rivet everything into place, and screw light is constructed to not be taken apart. It's going to be very rigid, very held together very, very strongly. Oh, where the hell did my other hole go? There. Okay. So now I'm going to move this driver out of there, and we're going to precision align it. Like that. Bam. All right, let's go ahead and start doing the hard stuff, which is going to be running the tubes here. Oops. Let me do we're going to do, oh, what the hell? Let me pull up my Amazon order real quick. Amazon. Hose. Tubing. Some Corsair tubing. So just so you can see the tubing. Oh, what the hell did it do? What the hell? Where in the hell did that? Oh, there we go. Okay, so here I ordered this. Hopefully, I can find the shit right. Size 10 slash to 13 millimeter, 3/8 inches. Was it ID OD? So inside diameter 10, outside diameter 13. So she's 1.5 millimeter wall thickness for our cooling tube here. We move that over off the side here. So it's a 10 on a millimeter. On the outside. To include 3D geometry. No, don't do that. All right. Let me back that off. I'm doing this wrong. Let me project this guy right here. Okay, there we go. Okay, include 3D geometry. We're going to do point spline starting there. 1, 2, 3. Okay. This is where the shit gets crazy right here. Insert spline. Do right there. It's not going how I want it to go. Doing wires and tubes and shit in 3Ds. It's fucking nuts. Okay, I'm gonna project both. That's what I'm gonna do. I'm just gonna start back. Okay, project that. Do 3D geometry. That, okay. One, two. Alright, let's come over here. Coincident relationship here. Alright. Oh boy, man, it's soaking up my graphics card. All right, let's see if I can loft this sucker. Or sweet. Ooh. Not the best there. We're gonna have to fix that a little bit. Let's come back in here and check around with that line. All right, then. This should be pretty easy. So water pumps. It's going to pump into here, out of here, then out of there, through this radiator, back out, back in, and gets cooled off as it passes through the radiators by the fans. Yeah, there we go. Rock and roll. I got to get these tubes down a little bit, though. They're a little higher than I like. I really don't. I got to just kind of... I got to be able to put them in without them kinking and bending too much. They've got to... We've got to fit in there nice and good, but... Yeah. Can actually achieve that. Well, actually, I have 90-degree fittings on here, so these are going to look... It's going to go on way cleaner than what I'm designing. I bought some 90-degree fittings on purpose, so... And I forgot to design them in. So probably the only thing I actually don't fully... I may design them in later. It may bug the shit out of me, and I just design them into here. But this is pretty much how it's going to roll here. Let's see how... Yeah, there we go. That's what it's supposed to look like. A little stretch there, I think. There. No, it won't look so shitty. If we do a render of it, let's do a render. Let's do a realistic render. That's pretty dope. Pretty happy with that. Go back to... So sheet metal here, the components. See if I can move it. No. Not gonna get that lucky, not today. I just got the design right where she's at. Sorry. how the fuck I did it. That's fucking way too many polygons, dude. I feel like I'll be doing that shit all day. Well, shit. I knew it freaking dance. I know it's a real, like, it was a real headache approach. Come back down here. One. Try that again. It's always like one little freaking thing, and it's gonna hang up and take forever. Well, I'm gonna jump off here, guys. I'm gonna go eat. 4 hours of drafting, and I'm getting defeated by a simple port right now. It's not wanting to flat out for me. It's really frustrating the shit out of me. Yeah, it's really irritating the shit out of me. All right, y'all have a good Friday. Have a great weekend. I'm gonna bounce off here, and I'll probably tidy up some of this, and I'll continue off with putting the diodes in. Maybe maybe tomorrow, maybe Monday. More likely Monday. We're just gonna put the diodes in. Bracket guide to kind of guide the wires to the diodes, and um, yeah, I gotta make sure I got clearance, all that good stuff. Make some little get some little clips I gotta make to hold the wires into place. But you'll have a good one.